Hey guys, in this video I just found out while solving some kinematics problems, I just found out a beautiful and yet very common concept. Like in the equation of motion, first equation of motion is v is equal to u plus at, right? Let's take this as equation first. This is equation, right? And the second equation, how we can make that, is like distance traveled while accelerating. Look, I will show you from this angle. The equation of motion is like, for this s is equal to ut plus half of at square. What does it say? It says that in an accelerated body, the distance traveled is equal to ut plus half of at square. But where from it came? It's a question, right? Let's suppose we actually had to find s, right? S. We can say, like, we can take v by t, no, v into t, right? Sorry, we can say, like, to find distance is equal to v into t. But the question is, we can change this, right? Means to increase the time, to decrease the time, we can get distance. But what to put here? Means what velocity we can put there? For that, we can also do the average of v plus u divided by 2, initial velocity and final velocity, right? Multiple by total time taken to make the total distance, to achieve the total distance traveled, displacement I mean, we can say, we can multiply it by t, and we can put the value of t anything which we want to make the equation perfect, right? But now the question is why we took this average here, average velocity. We could take like v anything, like for this you can just get misinterpreted. This we can say, like, why we didn't take x meters per second as a velocity, right? But we can take that s is equal to xt. But what, it doesn't make any sense if we put anything like 2 meters per second here, right? And we had to take out distance. But how we find the distance? We don't have clue. But if somehow from this equation, as Newton says that from this equation, it's an observatory equation also, it came true while observing the phenomena, while observing the motion also, it came out to be true, right? But the thing is, now if we do the observation and we place the value of this over there, and we multiply it by time. Now to make the equation perfect, we can take any value of t that which will satisfy this equation while taking the value of s from the observation. But will it make sense? It's actually a thought process which trigger my mind. Okay, will it make sense? No, it will not make sense. What we found out, we just make an imaginary equation and put imaginary time in it and to satisfy the equation. It doesn't make any sense, right? But how could, what if we insert u, initial velocity only? This also doesn't make any sense, because we have to take the time, then even more time, because if it's accelerated, not decelerating frame of reference, it's accelerating, means speed is increasing. Then in order to achieve the distance, if we already know that how much distance a person is traveled, in order to make equation satisfy, we will take more time, right? But it doesn't make any sense, right? What if we take v? Yeah, it makes sense now. S is equal to vt, and from the first equation, as I told you guys, v is equal to u plus at. Now if we insert v is equal to here, I will tell you, it will become u plus at multiple by t, right? By this, right? But now, as we did some sort of experiment, it means it's not only the mathematical analogy, it's rather an observatory thing. While after observing, means first of all we use this equation, and to make motion v minus u is divided by t is equal to a, right? It's the equation of acceleration. We move some body in an accelerated frame of reference. The distance it has traveled, we place it over there, right? Now after inserting this time, now the problem came, this time t and this time t is not didn't came to be equal, right? It was like this, ut plus a tt, not t square. Means this time and that amount of this time is not equal to the amount of this time. In order to make sense of this equation, if we take the same time, this the equation is not satisfied while inserting the value of s from the observation, right? If we take that like this, this was not this didn't make us understand what this actually didn't satisfy the equation from this from if we took this as this time, if we took this from the observation distance, it didn't make sense because it was actually the more this side RHS gives the more value than LHS we take from observation. I will write it here. But this we take from mathematics. But it was while observing, it came out to be more than this side, right? Means equation was not satisfied. Then what problem was there? As I told you guys, this time is not equal to this time. If we did this blunder, making this time equal, the RHS side came out to be more than LHS side, which came from the direct observation. But why? Because of this time problem. And now, as we know, the equation of motion there is half. But now the question is, why from we get this half, right? We could do also this thing as s is equal to like this, v plus u divided by t. It gives us average velocity, right? Average velocity. So if it gives us the average velocity, we multiple it by time, right? Because s by t is equal to this this velocity, right? It's actually the velocity here, right? After some sort of solving this, u plus at, inserting the value of v from the first equation, divided by 2 is equal to t. If we get u 2u plus at, right, divided by 2. After cancellation a little bit, we get s is equal to u plus at multiplied by t. Here is half part, right? But then if we further solve it, it came out to be ut plus half of at square. Now after getting the value from the observation of the distance and from this RHS which came from total mathematics, right? Total analytics, it came out to be true. It was satisfying the RHS and LHS rule. RHS is equal to LHS rule. Actually, I made it mistake. Actually, I write this here, and I should write this LHS here and this here, whatever it is. Now, LHS is equal to RHS, right? From the mathematics was getting the mathematical value was getting the same result as we get from the observation, right? But the question is, this came out to be true, but only when we take this as an average. But because of what? Because what it did, the average thing, it actually made these two times as equal. Means we can easily multiply it as we did there. Here, I mean, right? T square, and we write it as t here. And what was the problem? That RHS gave them more time, more distance than LHS, which came from the observation over here. In the past thing here was this problem of half. It was giving the more result because we didn't insert here half. Now the problem was solved out. Means what? It was not totally we can say like it was not totally based on mathematics at that time, but rather it was based on observation plus mathematics. We insert observation and then mathematics. But after Newton got derivation and differentiation and integration, means he actually invented differential calculus, right? He invented calculus. From that mathematics tool, it actually make us easy to understand why this equation was coming from here. If we do this over here from the calculus method, it's like ds by dt is equal to v, as we know that, right? ds by dt is equal to v. Now if we put here the value of the first equation, what we got here, v is equal to u plus at, over here we get the exact thing, u plus at. After solving a little bit, u plus at into dt. After integrating it 0 to s, obviously 7, it gives us s is equal to, and after doing integration from here, we get ud plus half of at square. By this actually we get this exact equation which satisfies the observatory thing, and which came from the observation, while observation doing that previous mathematics and observation. Without observation, this differential calculus made us understand s is equal to u plus at. Now this was the thing which came into my mind while solving some kinematics questions. I hope you understood what actually came into my mind, and basically it was just as a text note for me, for my future self, if I forget this. But rest, well, it was very good observation, and bye bye.